right there at the top. All right, so for posterity, this is the exam for review for the fall semester of 2023. In case this video gets used as another time, that's the time that I'm recording this thing. Today is what, November the 29th. Your exam is November the 30th. That's a Thursday. Okay, let's get started. I said without too much further ado, and I aim to keep it. So, first thing I want to mention, the very last page of our actual exam is this formula sheet currently on screen, and it goes for a whole page. Again, it's the very last page on the written exam. So if you want to detach that page just so that you can have it separate as you're working on the exam, because you get all these formulas, that is totally fine. In fact, I kind of encourage it, but you can also just flip to the back if you want to. If you do rip this page off, you do not need to turn it in with your exam. You can just recycle it when you're done. We don't need to see that page again. Again, that's if you detach it from your exam. But yeah, so again, you get all these formulas. They're on the very last page. With our first question, we are solving triangle ABC given this information. And that information is, or are, those bits of information are, side A, side B, and side C. So we have all three sides. So if we're going with that fancy naming convention, this is a side triangle, which means we've got to go to the law of cosines to solve this thing. Because it's possible to have an obtuse angle inside of a triangle, as long as it's a non-right triangle or an oblique triangle, like we've been looking at with these law of sines and law of cosines problems, we should solve for the largest one first. I talked so long I lost the original point. Let me try again. Because there could be an obtuse angle, we should solve for that potentially obtuse angle first. Because cosine inverse is the only inverse function that's capable of solving for obtuse angles. Sine inverse and tangent inverse cannot find an obtuse angle, but cosine inverse can. So since we're going to use the law of cosines, we should solve for that biggest angle first. That way, if it's obtuse, cosine inverse will pick it out right away. And we don't have to rely on sine inverse's sort of spotty coverage to figure out that last bit. So the only possible obtuse angle is angle C, since there can be at most one obtuse angle in a triangle. And angle C must be the biggest angle because side C is the biggest side. So this guy right here, solve largest angle first. Solve largest angle first. And again, that side bit, because we know all three sides, that must mean we need to start with the law of cosines. In fact, we're going to start with the law of cosines anytime our given information has one piece about each letter. So if we know something about A, B, and C at the beginning, we'll use law of cosines. We'll see in a minute if a letter gets repeated in the given information, like if I know side A and angle A, I'll start law of sines instead. But that's getting a little ahead of ourselves. So we're going to solve for angle C first. So we can go over to that formula sheet and see that C squared is equal to A squared plus B squared minus 2AB cosine of C. So we're going to pick out the version of the law of cosines that has angle C in it. Each of the three versions of the law of cosines is written for a different angle, A, B, or C. I mean, it's really the same formula, just with different labels in it. But we want the one that has angle C. So if I rearrange this equation to solve for angle C, that means I want to isolate cosine of C. So I'm going to add this 2AB cosine C to the other side, 2AB cosine C, the other side, leaving A squared and B squared where they were. And then also I'm going to move C squared to the other side. So A squared plus B squared minus C squared. I'm after C itself, which means I first need to isolate cosine C. So I'm want to divide that 2AB over to the other side. A squared plus B squared minus C squared all over 2AB. And then I can take the inverse cosine or the arc cosine of that right-hand side. And at this point, I'll start plugging in my numbers. So I know that A is 3.1. So 3.1 squared plus 5.2 squared. That's just a little bit off the screen. Minus 7.3 squared. All over 2 times 3.1 times 7.3. Nope, 5.2. There we go. Now I can get them all on screen. So I was just grabbing those numbers from the top, plugging them in for A, B, and C. And if I put that in a calculator and I'm in degree mode, I should get 121.1 degrees. Since I already went through the process of solving for that. So I'll put that in the box. C is 121.1 degrees. And then after that, so notice that C was obtuse. It just happened to work out that way. We had an obtuse angle, and cosine inverse was able to solve for it because cosine inverse is good at that, unlike the other two inverse trig functions. But after the first angle, it doesn't matter the order we solve the next two. So I'll get B next. And there's a few different ways we could go about it. But what I'm gonna do is back up just one step and highlight the only part where letter C shows up in solving for angle C. It shows up as A squared plus B squared minus C squared over 2AB. Through some substitution or some relabeling of those letters, I could say that if I wanted to solve for B instead, I'd want to have A squared minus B squared plus C squared on top. So I'm just switching the positions of B and C. Oh no, don't be like that. So I'm just switching the positions of B and C. So I'm not going to subtract 5.2 squared, but add 7.3 squared. And then also I'm going to switch out 5.2 in the denominator for 7.3. A shortcut step that you can take, since you've already got this in from this spot written into your calculator, you could just switch the negative sign in the numerator, swap out 5.2 for 7.3 in the denominator, and get an answer that way. Alternatively, you could use the law of cosine or the law of sines. But in the interest of time, I'm going to leave that there so we can try to get through the whole practice exam today. But the work for getting to B, if you wanted to see all of it, was the same work that we did to get C. Just solving for B instead. So B is 37.6 degrees. And now that we have two, oh, sorry, question, what's up?
Is it okay if, like, for example, like,
Yeah, so the question was, is it okay on the exam if we use law of sines instead of law of cosines, to solve for that second angle. And yeah, that's totally fair. I won't be picky about which method you use. Since law of sines will work to get that second angle. You have to use law of cosines the first time, but then after that, law of cosines or law of sines. Either one's fine, and I don't care which. So I'm recording this lecture as is, so you don't need the local recording this time for whoever just asked. This will be up shortly after class in its entirety. But for the last part, I want angle A. And once I know two of my angles, I really know all three because they all need to add up to 180 degrees. So 180 minus 121.1 degrees minus, I missed the 1 apparently, minus 37.6. And you can either do that in your head or plug it in a calculator. I think I get 21.3 degrees. Put that in the box. And once I've solved for my 3 missing pieces, I'm then done. So I chose 180 degrees here because I know that all 3 angles in a triangle have to add up to 180. So that's why I'd pick 180 instead of 90. So what happens if you don't solve for the largest angle first? So if I had solved for, say I solved for angle A first, which happens to be the smallest angle, and then I tried to use the law of sines to solve for angle C, the law of sines would give me angle C's reference angle instead of its correct angle. So when I solved for C using the law of sines, I would get, what is that? 59.9 degrees instead of 121.1 degrees. And by 59, I mean 58.9 degrees. Yep, that's what I mean. I'm good at math. The alternative way is if you solved for angle, the largest angle last, it would also still work. Because you could get A and B, since we know that they have to be the smallest. Law of sines will work to get angle B, because we know it cannot be obtuse. And then you could use the 180 trick to get C. So there are a few different ways to go about it. The most reliable and easiest way to explain is to just say solve for the largest one first. As long as you have a very solid grasp on how the inverse trig functions work, and specifically when they don't work, you can solve for it in whatever order you want. But saying that's a little dangerous, so for simplicity's sake, I always say solve for the biggest one first. But yeah, if you're feeling confident in those inverse trig functions, feel free to go whatever order you like. Just know that you're playing with a bit of fire. Next, I wanted the area of this thing. The area of this triangle, area. And I'm going to use the law of cosines version of the area formula, which looks like this. It is S times S minus A times S minus B times S minus C. And I need the square root of the whole thing, where S is the semi-perimeter, or the perimeter divided by 2. So I come over here and calculate that real quick. S should be 3.1 plus 5.2 plus 7.3 all over 2. That was A, that was B, and that was C for A, B, and C over here. We should find that semi-perimeter is 7.8. So I just have to plug that stuff into the formula. And we should get 7.8 times 7.8 minus 3.1 is 4.7. And then 7.8 minus 5.2, that's 2.6. And 7.8 minus 7.3 is 0.5. Plug all that into a calculator. I got 6.90. And that should be in square feet, since each of our lengths were measured in feet. All right, on to the next solve the triangle problem. So, right off the bat, I'm given two different sides and an angle. So this is either a side angle side problem, or it's an angle side side problem. The way to check for that is if a letter gets repeated in the given information, that means a letter gets repeated in its designation. So I can look here and see that I have letter A. Hello, I've returned. MSU's Wi-Fi is as good as we think. All right, did I miss anything else in chat? I don't even know. Okay, take me back to sharing this screen. Did it preserve my recording? It did. Presumably keep my recording going. So I don't know how much of that I was just babbling about got recorded. Professor Damaris, who that is. Take me back to what I was thinking about. We need to decide which of these oh yeah, that does make sense. Bring me back to the thing that I was talking about, which is deciding which order I need to solve for this thing in. Because we've got the two repeated letters in our given information, we have the AS triangle instead of the SAS triangle. When we've got this style, we're going to need to check for two triangles. And again, we'll know we have to do that because a letter gets repeated in the given information. With a repeated letter, we need to start with the law of sines. So the only thing I can solve for first this time is angle C, because I know side C and I know everything about A. So I'll set this thing up as the sine of C divided by C, which is 12.8, is equal to the sine of 58 degrees divided by 11.4. And in order to get C, I'll need to multiply 12.8 over to the other side, leaving me with sine C equals 12.8 sine of 58 degrees divided by 11.4. There we are. And if you plug all that into your calculator, you should get 0.9522. Just to check right here, this number is important. Ah, crap. accidentally hit the erase button as I was coloring it in. That number is important. If that number were bigger than 1, we would have 0 triangles. I think there's at least a WebWork problem that covers that, or maybe an online exam problem where you end up with an error right here. You'll also notice because if you try to solve for angle C, your calculator will give you an error. If that happens, that means you have no triangles instead of 2 triangles. The given information cannot be part of a triangle, is what that would mean. So if that thing's bigger than 1, you've got no triangle. But ours isn't bigger than 1, so we'll have 2. So why do we use sine and not cosine? We don't have the correct given information to make the law of cosines work. We would not be able to have only a single unknown in any one of our equations. Or I guess we could, but it'd be a quadratic equation and we'd have to do some like weird stuff with the quadratic formula to make it work. It is definitely not worth your time and effort. So don't use law of cosines on this one. We're using law of sines because we know everything about letter A. If we know everything about one letter, we know one ratio in the law of sines. The law of sines is just easier than law of cosines. And the other one, when you have 2 inputs, say, oh, right. Someone was just explaining what I did. Thanks, Lance. I could have read the whole thing first. Okay. Back to what I'm doing because I said I'm going to be on time today. Knowing that that's just a lie. Okay, so remember that sine inverse is really only capable of working in the first quadrant for us. So when I get the first possible angle for C, which I will call C1, it is equal to the sine inverse of that 0.9522 number. So 12.8 sine of 58 degrees divided by 11.4. It'll give me a number, and that number is 72.2 degrees. If I come over here and just draw a line to cut this problem in half. I'll also grab C2 right away. Because all I know is that C1 and C2 have the same reference angle because they both have the same sine value. So C2 is always 180 minus C1. And I got 107.8 degrees. So those are our 2 starting angles when we go to solve this problem. But now let's work only on one side. So after I've got C1, I'll solve for angle B1. Since as long as I know 2 of my angles, I also know the third. This is 180 minus 58 minus 72.2, all in degrees. And I got 49.8 degrees. Now that I've got that angle, I'll solve for its corresponding side. B1 divided by the sine of 49.8 is equal to 11.4 over sine of 58. Is that right? Yes, it is. Because I'll set it back to the information that I was given at the beginning. I was given A, so I'll keep setting it equal to A. Just for simplicity's sake. Or for the sake of not having too many rounding errors. B1 then is 11.4 times the sine of 49.8 degrees divided by the sine of 58 degrees. Which in turn is 10.3. And I believe we're in meters this time, right? Yeah, meters. So those three pieces together make up my first of the two potential triangles. Now I need to get the second. And to do that, I'll start working with angle C2 instead of angle C1. So I forget about everything I just did. I need to resolve for everything. The first step was solving for C2, although we got that one already. But once I have my first new angle, then I can go get my second new angle, B2. It looks pretty similar to our calculation for B1, 180 minus A minus C. But this time, C should be 107.8 degrees instead of the 72.2 degrees it was last time. So I want to plug in C2 instead of C1. Plug that into a calculator to get 14.2 degrees. And the only thing left is to get side B2. And side B2 is going to look like this. Let me scooch it down a little. 11.4 times the sine of 14.2 degrees over the sine of 58 degrees. Because I'm going to be grabbing that equation from right here. Since I already did the work in calculating it early, or calculating something very similar to it earlier, I want to use that again. Because the setup is still the same, law of sines with letter B and letter A. The only difference is that angle B2 is different from angle B1. So I'm going to swap out that 49.8 degrees in my formula for 14.2 degrees. And then throw that in a calculator to get 3.3 meters. Confused on why there are two of everything. So there's two of everything that wasn't given to us because there is ambiguity in the first angle that we solve for, angle C2. It's almost like I was prepared for that question. So this is a quick sketch of what those two triangles look like. The given information is angle A, which is 58 degrees in that lower left corner. That thing is fixed. That cannot change. I know that side C is 12.8, so that's that solid black line that I drew in. That is a fixed value, it cannot change. The things that can change are all the parts that aren't given to us. So side B1, which is the thing, side of the way that I drew the triangle, side B is that horizontal line down at the bottom. It's not given to us, or at least the length isn't given to us. All I know is that it needs to exist somewhere along that horizontal gray line, but I don't know its length. The other length that I do know is side A, which is 11.4. So the red side opposite angle A. I know that it's 11.4, and there are two ways that I could. And we're back again. Hey, everyone. Put me back here. It's a good thing I saved these recordings from last semester, because I'm going to need a couple extra this time, just in case this recording is totally scuffed. But okay, so I think the spot where I was saying that 11.4 meter side is fixed. So those two red lines are stuck. But either one has a length of 11.4 and keeps the other given information the same. So the first thing I solved for was angle C1. And there are two angles that have the same sine value of about 0.9522. Those two angles are C2 and C1. One of those is acute and the other is obtuse. And so because both of those two angles solve the initial equation that I have, there are two potential triangles that match up with the given information, which is why I've got to solve for two of them. I am not going to ask you to draw this picture because, well, it's a little on the complex side to get there. But if you can understand everything in this picture, I think you've got a very good grasp on this material. And if you can't, then oh well. Yeah, how do you know when you're going to have one triangle or two? And it's when it's an ass triangle. When you have one angle and two sides and a letter is repeated, that's when you know you're going to have to solve for two. All right, so letter A is repeated in the given information. So S is repeated in the designation of the triangle. That's how you know you need to solve for two. Another really good way to know that you're going to need to solve for two is if you look at two solve the triangle problems and one of them is worth about twice as many points as the other one, probably that second one is going to have two triangles. If you wanted a good test taking tip. But all right, we are definitely behind the time that I was hoping we'd be at, but that's nothing new. Okay, let's look at a word problem. Oh yeah. So Coast Guard Station Brave is 47 kilometers due north of Coast Guard Station Courage, and an airplane is forced to make an emergency water landing sighted by the two Coast Guard stations. Bearing of the airplane from Brave is that top one, 57.4 west of north. And the airplane from Courage is 32.1 degrees west of north. How far is the downed airplane from Coast Guard Station Courage? And if you'll read through that given information, you'll notice that each of the three things conveniently are labeled with letters A, B, and C. There is an airplane for A, and there is Courage for C, and then there's also, hey, come back. Yeah, that makes sense. There's also Brave for B, and the instant we can get the Wi-Fi to keep working, my pen decides it wants to be lame. So let's go to chat real quick. I read something that said if the second angle is bigger than your original, it has two triangles. Is that true? I think that's not necessarily true. It could be true, but not always. We always have to check for two whenever, what is it? We just always have to check for two triangles whenever we have a repeated letter in the given information, is really what it comes down to. I think I may have found a way to fix this pen reliably. Yep, still broken. And oh yeah, it's working. We're learning. Although Zoom is freaking out. But whatever. All right, and as I was saying, Brave. B. Cool. A, B, and C. Conveniently. So let's draw what we have going on. I need a ruler and a this colored pen. So on here, I've got Courage. What did we say at the beginning? Brave is 47 kilometers due north of Courage. So I'm going to draw a line that runs north and south, and then label my two Coast Guard stations. B for Brave and C for Courage. And what else do we know? We have two sightings of a downed airplane. The first was a 57.4 degree bearing, which is actually going to look like a 33-degree angle here, because it'll be 90 minus that number. So one of our sightings is here. And the other one was a 32-degree bearing, which if I come back to 90 and take off 32 degrees, I'll get to right here. Place that over top of Courage. Hey, come on now. There you go. All right, and since I happen to have a compass and a straight edge, I can draw an accurate diagram here. So the spot where those two sighting lines intersect must be where our downed airplane is. So that's A. It's going to be that angle there, and conveniently, angle A is the one that is listed. Other things I know. The bearing from Courage is 32.1 degrees. But here's the tricky part. The bearing from Brave, which was 57.4 degrees, is actually that angle outside of the triangle. Where angle B is actually this angle in blue on the inside. Just be a little careful with that, because we'll need to do a quick math step to get angle B before we start solving for the rest of the triangle. Oh, the last thing we have, the distance between our two Coast Guard stations is 47 kilometers. And that distance is opposite angle A, so I'm going to label it in red. But ultimately, the thing that we wanted was the distance between point A and point C, which somewhat counterintuitively is length B. So I want to solve for side B. It's my goal here. In order to do that, I need to know all my angles first, because I'm going to want to use the law of sines, which means I've got to get angle B. So angle B should be 180 degrees minus our bearing angle of 57.4, which comes out to 122.6. I can read my own handwriting. And then I want angle A, which is in red. So I know that all three angles have to add up to 180. So I want 180 minus 32.1 minus 122.6. And that in turn is 25.3. And with that all together, I can go solve for side B. So I'll set up a law of sines ratio, which should read something like B divided by the sine of 122.6 degrees is equal to A, which is 47, divided by sine A, which we just got was 25.3. So then B itself is 47 times the sine of 122.6 divided by the sine of 25.3, and plug that into a calculator. And I got 92.7. And in kilometers. Cool. So that airplane is 92.7 kilometers from Courage. If I were to change this problem slightly for the exam tomorrow, I might ask for the distance between the airplane and Brave instead of the distance between the airplane and Courage. In which case you'd solve for side C instead of side B. Just as a, possibly helpful hint. Can't possibly imagine why I'd think of that. But I digress. Okay. Number 4, an easy one. Finding just the area of this triangle. And there's exactly enough information given to use one of our law of sines area formulas. So that one, I believe, would say that the area is equal to 1/2 of C times A times the sine of B. There were 3 of them all together. So there was AB sine C, there's CA sine B, and then there's also BC sine A. All 3 will work. We happen to have this one, so I'll just plug that stuff in. 1/2 of C was 4, A is 12, and angle B is 81 degrees. Plug it all in. Plug it all in to get 23.7. That's square centimeters. Will these formulas be on the formula sheet? Yeah, they ought to be. I just go grab that formula sheet real quick. I moved it up at the top. Yep, they are right here. And of course, I took the one in the middle. So it's the one that had my 3 pieces. Okay, and then I think the last couple of problems. Now we're going to move on from the solve the triangle type problems and go back to the sum, difference, and double and half angle formulas. So this one should look like, well, first I want to notice that 3 pi over 8 is equal to half of 3 pi over 4. If you remember this problem from worksheet 12. I know that 3 pi over 8 is in quadrant 1 because it's in between 0 and pi over 2. The 3/8 pi to 1/2 pi. So I know I'm going to be in the first quadrant. And that half angle formula plus or minus the square root of 1 minus cosine theta, or this one's going to be 3 pi over 4 all over 2. And because we're in the first quadrant, we'll take the positive value. So this thing is positive. The square root of 1 minus negative root 2 over 2. Since the cosine of 3 pi over 4 is negative root 2 over 2, divide it all by 2. And we'll simplify this square root real quick. Multiply top and bottom by 2 to get the square root of 2 plus the square root of 2 all over 4, which in turn simplifies to the square root of 2 plus the square root of 2 all over 2. Oop. Let's check that going on. Trying to solve a law of sines problem, but keep getting 1 as the answer when comparing two angles and one side. What necessarily am I doing wrong? I'm guessing, Robin, that you're in radian mode instead of degree mode. Is what that sounds like to me. But I could be wrong. How do I know which quadrant? 3/8 is more than 0, but less than 1/2. So I knew that was quadrant 1. Oop. Chat immediately had something new going on. I'm gonna skip that for now. It'll be in the recording later. Oh boy. Okay. So let's solve. Man, yeah, I'm always over on time. This isn't a surprise. Okay. Solving this trig equation. Cosine of 2 theta is equal to cosine theta minus 1. Find all angles in 0 to 2 pi. Is this one in there? So the way to do this one, I'm going to go through it quick. I don't think this one's on our exam. But I put it on the practice exam, so I must have known what I was doing at some point. Cosine of 2 theta. I can use the double angle formula to say that that's 2 cosine squared minus 1. And that's equal to cosine theta minus 1. My goal is to solve this thing for theta, so I'm going to gather up all my terms on one side. So I'll have 2 cosine squared of theta minus cosine theta plus 0 equals 0. So notice that the minus 1s on each side will add up to 0. So they're gone. Hi. So that's a good question. So it is similar to an example from worksheet 11, but it also has a double angle formula from worksheet 12. And I put it on the practice exam for a reason. I would have to believe I put it on the practice exam for a reason. I know that this is not on the written exam tomorrow. But if it's on the practice exam, that probably means I put something similar in the online exam. And I'm just forgetting about that. But I was also kind of surprised to see this problem here. But I'm gonna believe in the me that wrote the practice exam and say that it's here for a reason. Don't spend a ton of time focusing on it though. So I don't think it's that important. And definitely you don't need it for the written exam tomorrow. But it ended up on here, so let's pretend like it's important. I would then factor out a cosine of theta, leaving with 2 cosine theta minus 1 equals 0. Why did that turn off? That's probably fine. And then that'll give me 2 options. Either 2 cosine theta minus 1 equals 0, or cosine of theta equals 0. Actually. And then solving those 2 parts, either cosine theta equals 1/2 or cosine theta equals 0. From the unit circle, those possible angles are pi over 3, 5 pi over 3, pi over 2, and 3 pi over 2. So again, not on the written exam tomorrow, but might be on the online part of the exam. And to set this one up real fast, we ultimately need to find cosine of u over 2, which means I'm going to need an inequality for u over 2. So I'm going to multiply that thing by 1/2 and start working from there. So I know that I am over on time. So if you've got another class to get to, it's not going to hurt my feelings if you got to leave right now. I'm going to stick around for hopefully the next like 5 to 8 minutes to finish up this practice exam. Just so that it's in the video that will maybe work when I try to process it later. We'll find out. But if you gotta go right now, good luck on the exam tomorrow. This exam review will be posted hopefully in the next hour, along with I'm going to post the videos from last year as well. Just because I don't know if the video is going to work with the number of times that Zoom crashed. But okay, what do we have going on? Oh, here. Is the allowed formula sheet with the practice exam the same thing we will get for our exam? Yes, it is that same exact exam. You will see it on the exam itself tomorrow. Okay, so with the people that are still sticking around, let's blaze through this as fast as we can. Figuring out a reference triangle. U itself is between pi over 2 and pi. That's the second quadrant. So I'm going to draw my reference triangle in the second quadrant. And then put the coordinate axes on there. Kind of there-ish. So angle U is this guy. From the fact that tangent is opposite over adjacent, I know that root 39 goes there and 5 goes here. And we're in the second quadrant, so our x values are negative. So I'll put the negative on the 5 and not on that root 39. I need to solve for my hypotenuse. C squared is 5 squared plus root 39 squared. So 25 plus 39 is 64, meaning that C is 8. How about we highlight that in blue? So that's my reference triangle complete. I also needed that inequality for u over 2. So come back to the spot where I multiplied my initial inequality by 1/2. And I should get that u over 2 is between pi over 4 and pi over 2, which puts it in the second half of quadrant 1. So u being in quadrant, u over 2 being in quadrant 1, but u itself being in quadrant 2 means that the rest of the setup ought to look like this. This is going to be plus or minus the square root of 1 plus cosine of u over 2. And because u over 2 is in the first quadrant, I want the positive value. Hi. Gotcha. Where did I get the pi over 4 and the pi over 2 from in that inequality? This chunk right there goes together. Then what else have I got to get here? I know I said I wanted the positive out of that plus or minus option. On the inside of my square root, I want 1 plus cosine of u. Go back to the reference triangle. It's negative 5 over 8. All over 2. I need to multiply top and bottom by 8 to get the square root of, this will be 8 minus 5 over 16. And then I can simplify that. 8 minus 5 is 3, and the square root of 16 is 4. So again, this thing is positive because u over 2 was in quadrant 1. Which quadrant would make it negative? Because this is cosine, quadrant 2 or 3 would make it negative. And we'll call that good enough. Okay. And I've got one last problem to knock out real fast. Hopefully we're done by 1:40. So I need the tangent of sine inverse of a number minus pi over 4. So remember that the sine inverse of a number is just going to be an angle. I'm going to call this one alpha. So the thing I'm solving for is going to be the tangent of alpha minus pi over 4. Pi over 4. So I want the tangent of alpha minus beta formula, where beta just is pi over 4, a known value from the unit circle. If I grab that formula, it's tangent of alpha minus tangent of pi over 4, tangent alpha minus tangent beta, pi over 4. All of that, if I had a steady hand, will be over 1 plus tangent alpha times tangent of pi over 4. So this thing is going to be some number minus 1 divided by 1 plus another number times 1. I need to figure out what that number is. And to do that, I'll need a reference triangle. So I'm going to go back to sine inverse of negative 11 over 61 and create a reference triangle. So I need a triangle that is in the 4th quadrant. So I'm taking the sine of a negative number. Let's try again. So my angle alpha is that guy right there. Sine is opposite over hypotenuse. So I should have 11 for my opposite side, 61 for my hypotenuse. And because I'm in the 4th quadrant, my opposite side should be negative. So I need to solve for my adjacent side. So I'll set up the Pythagorean theorem. X squared plus 11 squared is equal to 61 squared. So that's x squared plus 121 is equal to 61 squared, which is 3,721. Meaning that x squared is 3,600. So x is the square root of that, which is plus or minus 60. Because we're in the 4th quadrant, our x value should be positive, so 60 goes right there. Now, from that reference triangle, I need the tangent value, which is opposite over adjacent, which would be negative 11 over 60. So I'll plug in those values into the formula, and then it's just a simplify this equation. I have too many denominators, so I'm going to multiply top and bottom by 60 because that's the extra denominator that I have. Doing so should get me, let's see, negative 11 over 60 is just negative 11 minus 1 times 60, which is 60, divided by 1 times 60 is 60, minus negative plus negative 11 times 60, which is minus 11. So add up the numerator and the denominator. I got negative 71 over 49. Yeah. And then that takes us to the end of the practice exam, barring a couple of technical difficulties in the middle there. And I'm only like a little bit over 140. Okay, cool. So I'm going to end things there unless someone from my class who's still here has a question for me. And it looks like I've got at least something in chat. But with that said, good luck on that exam tomorrow. I believe in you. I will see you all next week. Yeah.
So for that, like, the last problem, do you multiply 1 by 62 or no?
Yeah, I did. So it's the 60 gets multiplied to this fraction and the 1, and the denominator also gets multiplied to the 1 and the fraction.
Do you get multiplied to that one
But
too?
this one, so this is negative 11 over 60 times 1 times 60.
Okay.
But I don't need to multiply it to each individual piece
Okay.
because that would look like an exponent
Okay.
rather than just multiplication.
Okay. And then for this, like, I just wanted to know, like, how did you do this?
Oh, that is a formula on the formula sheet. Cosine of 2 theta is equal to 2 cosine squared
Okay.
of theta minus 1.
On the formula, like it's for the identities, or it's going to be on that? It's on-
Oh no, it's on the formula sheet you get tomorrow.
Okay. Thank you.
Yeah, for sure. You're welcome. Okay. What do we have going on over here? And I know I'm gonna have to give up this classroom shortly to what I think is calculus. So let me start doing this a little bit better. Oh my God, chat, figure it out. It's not that complicated. Sorry, yelling at my computer. I'm sure that's helpful. So why is that thing in quadrant 4? I'm taking the sine inverse of a negative number. And remember the awkward way that sine inverse is defined. It can only be in quadrant 1 or 4. It's not positive, so it's quadrant 4. What if pi over 4 wasn't a point on the unit circle and was a more complicated fraction? Either this problem will give you a value you know off the unit circle, like pi over 4, pi over 3, pi over 6, something like that. Or it'll give you another inverse trig problem, in which case you'd create a second reference triangle. So either you use the unit circle or you use a reference triangle. Those are the two methods we have. You would not see something like pi over 5 because we don't have a good method to solve for that, at least not with the toolkit that we've been building. And is it in quadrant 4 because sine is negative in 2 and 4? Well, sine is really negative in 3 and 4, but it's more about the fact that this is sine inverse, as I said a minute ago. Oh yeah, for sure. You are welcome. And is that the same for all the inverse functions? No. Sine inverse and tangent inverse will both go to the 4th quadrant if they're negative, but cosine inverse goes to the 2nd quadrant if it's negative. We saw that earlier when we were solving for the very first triangle, and we took the cosine inverse of that number to get an obtuse angle. So cosine inverse works in the 2nd quadrant, whereas the other 2 inverse trig functions work in the 4th quadrant. Yeah, sure, I can try that again. So sine inverse, and so first off, all 3 inverse trig functions work in the 1st quadrant as long as we have a positive number. But if it's a negative number, we have to go to another quadrant. Sine inverse and tangent inverse both go to the 4th quadrant, where cosine inverse goes to the 2nd quadrant if it's negative. And the example I used there was recalling back to our very first problem from this practice exam, where we took the cosine inverse to solve for angle C and we got that obtuse angle. I believe it was like 121.1 degrees. And so that's because cosine inverse works in our second quadrant. It can give us obtuse angles if there is one. Ooh, yikes. All right, and I am going to give up the classroom for the calculus class that's next. So I am out of here. All right, cool. Good luck on that exam tomorrow. And I'm going to end the recording right here.